Hi, welcome to our video. Our project examines robot cab and autonomous taxi services that prioritize efficiency over accessibility, excluding wheelchair users and others with mobility needs. We identify this as both a technical oversight and an ethical failure in smart city design. Using different ethical design tools, we developed accessibility optimized routing, a prototype that embeds inclusion into navigation algorithm. Because mobility tech shouldn't just work, it should work for everyone. We addresses an ethical issue in autonomous navigation, the exclusion of accessibility needs. Robot cab use rental navigation optimized for time and distance, but ignore critical accessibility factors like crop cabs, ramps, and sidewalk conditions. Therefore, safe and dignified access for mobility impaired user is not guaranteed. This case reviews the ethical harms in technology. Users may be stranded in unsafe locations, experience exclusion, lose trust in public tech, and face added burdens. Take Emily, a wheelchair user. The system dropped her at a crowd with no ramp, leaving her stranded in the rain. This wasn't just a glitch, it was exclusion by design. Technology must serve everyone, not create barriers. This case isn't about technical failure, it's a social and moral one. As Miner notes, system can function perfectly yet still fail ethically. What is robot cab's flaw? A value failure. It prioritizes speed and efficiency but ignores accessibility and inclusion. Values never explicitly debated, just assumed. The result is a system that works technically but fails those who need it most. It's a reminder, when we design, implicit values become explicit consequences. AI systems inherit society's biases. As Bender's stochastic parrots shows, navigation's algorithm trained on able-bodied data make wheelchair users like Emily invisible. This isn't intentional exclusion, it's structural irrational where technology ignores minorities by default. True innovation demands designing from the edges, centering the excluded to build for all. The failures in robot cab could have been avoided by applying value-sensitive design, which focused on including human values like accessibility, autonomy, and fairness in the design process from the beginning. VSD encourages identifying stakeholders and their needs, ensuring these values are considered. Had VSD been applied, users like Emily would have been recognized as key stakeholders. This would have led to more inclusive features such as accessible routing data, user overrides, and interface prompts for accessibility preferences. Emily's case also raises a broader ethical concerns. From a clear ethics view, the system fails to recognize and respond to the needs of vulnerable users like Emily. Kenshin's ethics shows it treats her as a means to efficiency, not as a person with dignity. And even from a utilitarian lens, the harm to small group outweighs the time saved for the majority. Ethical design must go beyond functionality, it must center inclusion, dignity, and care.
For this project, we chose the value map as one of our ethical design tools because it helped us clearly identify all the different stakeholders affected by our design challenge, and more importantly, what values each of them care about. We hope that this tool would help us visualize the value tensions across groups so we could better understand the ethical conflict and redesign accordingly. We started by listing out 20 stakeholders, both direct and indirect. For example, we included users with mobility impairments, but also urban planners, insurance companies, and even taxi users with disabilities. Then, we mapped their values using 3 segmented circles, each representing a stakeholder group. For instance, mobility impaired user value accessibility, safety, and comfort. Auto taxi company prioritize efficiency, service coverage, and cost management. We connected this with value tensions like efficiency versus user accessibility, comfort versus head speed, and cost versus routing simplicity. This became our value map, shown here to support our analysis. Using this tool helped us find the core ethical issue. Current navigation systems are often optimized for speed and simplicity, but this comes at the expense of users with special accessibility needs. This insight wasn't obvious to us until we visualized the value this way. It was definitely an aha moment. The value map gave us a clear structure to explore the ethical gap, and it directly shaped our prototype idea, which focuses on offering more customizable, accessibility-aware routing options in the system. That's all about the value map, and my teammates will introduce more on the ethical design tools part.
We use social failure mode analysis to explore how robot cabs relies on Google Maps for navigation. could lead to ethical failures, especially for people with mobility impairments. Why this tool? It reveals social risks, cases where the system works technically but still violates expectations of fairness, dignity, and inclusion. Our goal was to understand how robot cabs' routing behavior affects key social norms, and where the system might exclude users through ethically blind design. We began by looking at the social environment. People with mobility impairments often face barriers like narrow sidewalks, high curbs, or inaccessible stop points. Based on this, we identified two important social norms: the right to dignified and equitable access, and the need for predictability and assistance, like extended boarding time or stop customization. To visualize our analysis, we created a social norm mapping diagram. It showed how robot cabs' default navigation behavior violates these norms by dropping users at unsafe locations or failing to respond to access needs. This led to our aha moment. The problem isn't just poor optimization, it's a norm transgression. This system quietly undermines users' trust and inclusion. As Miller notes, without embedded value like fairness, systems can cause structural harm. In response, we propose a design direction: treat accessibility as a core system value, avoid unsafe stops, respect autonomy, and support mobility needs. More broadly, ensuring justice in access is an ethical obligation. As Young and Friedman argue, public systems must reflect inclusion and fairness, or risk long-term social failure.
For this project, we chose the ethics setting map as one of the ethical design tools. The main reason is that it helps us clearly connect the ethical issue with particular design features. By using this tool, we aim to identify key settings within Google Maps that may impact our prototype and analyze who has access to those settings. First, we used this tool to break down the logic of route planning and discovered that its default efficiency-first algorithm, focused on factors such as the shortest travel time and avoiding busy traffic, only caters to typical users' needs. It completely overlooks the requirements for ease of access when it comes to pickup and drop-off locations for people with mobility challenges. This tool helped us realize that during prototype design, the ethical settings for these stop locations should be configured as user-adjustable variables rather than being hardwired. Next, we analyzed the route preview step by step and found a key design flaw. In the case of the Ottawa hospital, the system doesn't clearly show where the ramps or curb cuts are near the drop-off point. This forces wheelchair users to cross potentially unsafe areas, increasing their risk of physical harm and making them feel excluded by the system. From the street view, we can also see that the default drop-off spot is in a busy area with lots of foot traffic and vehicles. There are no clear easy access paths nearby, which obviously fails to meet the basic needs of people with limited mobility. By applying the ethics settings map, we realized that most of the control over route settings is held by platform developers. That creates a kind of black box system where only they can change the key settings. Important stakeholders like hospital staff or people with limited mobility don't really have a way to mark safe paths or warn about unsafe drop-off spots. That's when we had a light bulb moment. The core ethical issue here isn't just about missing features. It's about how control and decision-making are unfairly divided.
Now, I'll present our prototype solution, accessibility optimized routing and stopping for rob-out cab, addressing how autonomous vehicles often select inaccessible locations for people with mobility impairments. Our first feature is the accessibility profile. Users select their mobility device and specify critical requirements like maximum curb height, ramp needs, and extended wait time. This preference applies to all feature rights automatically. The route selection screen offers both standard and accessibility optimized routes. The accessible option clearly displays verified features like ramp access and wide sidewalks, allowing users to make informed choices despite the slight cost and time differences. For both pickup and drop-off, our system shows key accessibility information and allows users to adjust exact locations. The pin automatically snaps to verified accessible spots, ensuring safe access at both ends of the journey. This prototype addresses the ethical issue by prioritizing accessibility over speed. By providing verified information and location control, we shift decision-making power to those most affected. However, 3 limitations remain. First, who will maintain accurate accessibility data? Second, is it ethical to charge more for accessible routes? Third, further testing must include all mobility impairments types. Future work includes testing in various conditions and developing fallback options when fully accessible routes don't exist. This solution addresses exclusion in autonomous navigation while supporting dignity and independence.